Hello everyone, this is my extra credit for chemistry. This is question 2, and I'm splitting it up into 4 parts. So, question 2, find the... Oh, I forgot to write isomers. Find the constitutional isomers of C4H7Br and name them. So, but first, when you have a problem like this, you should use the degrees of unsaturation formula to find how many rings or multiple bonds, but in this class we're only going to focus on rings. So I'm running it here and fill it out. So carbon 4 plus 2 minus 7 hydrogens minus 1 halogen and then plus 0 nitrogen. Notice X is like a standard for halogens. And then 2 equals divided by 2 all this, so 8, 10, 3, 2, and then equals 1. So there'd be 1 ring. And so we need to find 4 of them. So let's start. So we know there's 4 carbons. So if we were to probably the most obvious one that you're thinking of is just put the carbons in a square because we need 1 ring of carbon. And let me draw this better. And then just add a bromine at the end to one of them. So let's just try it and just count. So there's a hydrogen here, hydrogen here, hydrogen here, here. And then there's a hydrogen here because you need to fill out the octet rule for this this carbon, so don't forget to add that. So 1, 2, 3, 4, 5, 6, 7 hydrogens, 4 carbons, 1 Br. And does that fill out what we're looking for? Let me rewrite it here. Yep, so this one checks out. So since we can't do any more, I guess you could try to like rotate the bromine around the square, but if you were to do that, then you would just be having the same atom. So that doesn't work. So we're gonna have to use. So if we still want a ring of carbons, the next geometrical shape is a triangle, and then we have 1 more carbon, so we're gonna stick that at the end, and then with that 1 more carbon, we have to place a bromine. So where do we place this bromine? We can place it here. So count out the hydrogens to make sure. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1 bromine. Does that fill it out? Yep. We can't go down. If we still want one ring, the minimum we need to find 2 more isomers. So where else can you place the bromine from this shape of carbons? You can just place on a different carbon. So count it out. 1, 2, 3, 4, 5, 6, 6. Wait, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4 carbons, 1 bromine. Checks out. So this last one is probably the most tricky one. You would think you just need to rotate this bromine to this other one, but that would just be ending up making the same atom. So you think creatively. So if you can't put it in this one, because I'll make the same one, you can put it in this one. I'll make this one, you can't put it on this carbon, because I'll make the same one as the first one, or the one up here. So which other ones can you place it on? You can place it on this one right here. So let's try that. I'm gonna erase these circles. And let's see if that works. One, two, three, four, five, six, seven. 7 hydrogens, 4 carbons, 1 bromine. That checks out. So now we found 4 isomers. All we need to do is to name them. So what you first need to do is find the longest chain or ring. So for spoilers, but for all of them, the ring will be the longest. And whenever you want to do that, you should just circle the ring, so you know you don't have to like rename those atoms or repeat those atoms in its name. If that makes sense. So now we just need to write down. Once we have that, we can write down the parent name. So there's 4 carbons, and make sure you remember your I forgot what it's called. It's like what the numbers correspond to which name. So one would be methyl. I don't have the list on me, but make sure you put that in your cheat sheet. So 4 would correspond to a butane, not propane. I don't know why I was writing that. So there's 4, so you need 4. You need but, and then it's a ring, so you need to add the prefix cyclo, and it only contains what is it called? Carbon bond. So it would be a alkane, so you need to add the ane at the end. So when you put that all together, the parent name would be cyclobutane. And none of the parent name goes at the end, so now we just need to substitute. So the substituent, we should number it. Make sure you go counterclockwise to see if it makes a difference. And always start naming at the first substituent, so does it make a difference? So we have the first carbon, we have 1 bromine, and then when you write bromine or any halogens, I'm not sure if it's any halogens, but bromine specifically, you change the ending to bromo. So put these together and you get 1 bromo cyclobutane. I'm just do the same thing here. We already circle. Oh, that's a bad circling. So we need to circle the longest chain, and then we need to start numbering. 1. No, you don't have to start numbering now. So we start writing down the parent function. So it's 3. The number that correspond, or the phrase that correspond to 3 is prop. And then it's a ring, so it's cyclo. And then it only is carbon bonds, so to end to end, so put that together. And the parent function is cyclopropane. So now we just need to name this constituent. So first you find the longest chain of carbons, which would be, and then when you're finding the longest chain of carbons, you don't count the carbons you already circled, so it'd be right here. So that'd be methane. Or you need to restart the naming cycle, so you find the longest chain of rings or not meth, okay. you need to find the longest chain or carbon or longest chain or longest ring. Sorry for that. And when you find the longest chain or ring, you label it. So 1 corresponds with methane or meth, and then because it's a substituent, you just add the methane, like the YN at the end. But there's also something attached to this methane, so it's like a substituent in a substituent. So like before, it'd be just 1 bromine. So there'd be like inside this one substituent be 1 bromine, and then you just combine these. So you have 1, and then this one takes precedence because this is the pen function. So just because this is the parent function, so I put 1 parentheses. Let me erase this and start very small so it fits. 1 parentheses because this is a substituent inside the substituent, so maybe 1 bromo methane, and then add this cyclopropane. Just imagine if I wrote the ending there. So let's work on this one now. Pan function, it'd be the same thing as this one, cyclopropane, because it has 3 carbons and all carbon bonds, and then it's a cyclone, or it's a ring, so it'd be cyclopropane. Now you need to start numbering. 1, 2, 3. 1, 2, 3. And then you can tell which numbering system to use because of first part a difference. So the first part difference of this one, it'd be like you can label out which one has a substituent. So let me color code this. This is 1, 2, 3. So it'd be 1, 2. That's where all the substituents are for that numbering system. And this numbering system is going to be this color. So 1, 3. So first point difference would be the second one, and then you want to choose the lowest number. And that's how you choose your number system. So lowest number is 2. So you choose the green one. And now we can start labeling what's on each. It's 1 bromo. Attribute 1 is 1 bromo. And then attribute 2 to the methane, because there's 1 carbon here. And then you you do the prefixing 1 goes to math, and then you add the N, or not N, the YN at the end because it's a substituent. Now we just need to put this all together. So it'd be 1 bromo, 2. Oops. And this is why it's very important to have the parentheses on this one, because no, I'm talking about a different one. Ignore that. Okay, it goes here. Just imagine having enough space to write that, and that would just go there. Now let's work on this last one. It has the same parent name as other ones because it has 3 carbons. 3 corresponds to probe. It's a ring, and that's all carbon bonds. So it's a antiphane. So parent name would be cyclopropane. So, this is a bad circling too. So just start labeling the bonds that are you do the numbering 1, 2, 3, and then all bonds are 1. So let's start naming this persistence. So this is why I messed up earlier. So this is why it's important to have like the parentheses in order to signal that this is a substituent inside substituent, because for this one, like if I were to not, it would look very similar and it can get confusing. So you just, and then you might be confused which one goes first, the bromine or the methane. The bromine go first because alphabetically it starts first, so it'll be 1 bromo, 1 methyl. And then add this at the end. Okay, I'm gonna space to write that. Then that would be the names of all 4. So just to do like a quick recap of what you need to do. What you need to do is to use degrees of saturation. Once you do degrees of saturation, you just need to like draw 4 of them. So this one, you could, there's a table, I just don't have it on me, but like so you can find like easily, you can easily know which one it is. But for this one it's pretty easy. There's only 4 carbons, so we know that there's a square version. And make sure you just check. You don't, I mean, once you get good enough you don't have to check, but I just like to check so I know. And then you first start with finding the longest chain or ring and write down the parent function, the parent name, and you start naming the substituents and just add the parent name at the end. So that's about it. Thank you. Have a nice day. And should have questions 3 and 4 commented below this one.